Imagine, 500 light-years away, a world with an atmosphere that breathes, evidence of life beyond Earth. Picture a planet orbiting a distant star, its skies swirling with clouds, its surface touched by alien winds. For centuries we have wondered if such a place could exist, if life could take root in the vastness beyond our solar system. Now, for the first time in human history, we have clear chemical proof, not just speculation or hopeful theory. Scientists have detected unmistakable signs, molecules in the air that can only be explained by biological processes. The data is robust, the evidence compelling. On August 7, 2025, the James Webb Space Telescope allowed us to finally listen to the universe's secrets. This marvel of engineering peered deeper than ever before, capturing the faintest whispers from a world so far away, yet now so close to our hearts and imaginations. This is no longer science fiction, this is our new reality. The boundary between imagination and discovery has blurred, and what was once the realm of dreams is now a fact of science. The search for life has driven us for centuries, inspiring generations of astronomers, philosophers, and dreamers. Today we have a definitive answer, one that will echo through history and reshape our understanding of our place in the cosmos. The data is unambiguous, a clear, persistent signal from a distant world, shining through the noise of the universe. It is a message written in the language of chemistry, waiting for us to decipher. The James Webb Space Telescope has detected the unmistakable fingerprints of biology in an exoplanet's atmosphere. These are not random patterns, but the telltale signs of life, gases that should not exist without living processes to replenish them. This moment will be written into every textbook, a turning point in our understanding of the cosmos. Children will learn about this discovery as the day humanity realized it was not alone, a milestone as significant as the first steps on the moon. The silence of the universe has been broken. We are not alone. The cosmos, once thought empty and indifferent, now whispers back to us, hinting at life beyond our wildest dreams. The story of our universe just became infinitely more interesting, and we are the generation privileged to witness it. As we look up at the night sky, we do so with new eyes, knowing that somewhere out there, another world is breathing, and the universe is alive with possibility. To truly grasp the magnitude of this discovery, we first need to understand the James Webb Space Telescope, or JWST, a marvel of modern engineering and the most ambitious space observatory ever created. Launched in December 2021, after decades of planning and international collaboration, JWST represents a giant leap forward in our quest to explore the cosmos. It was designed to peer deeper into the universe than any telescope before it, unlocking secrets from the earliest moments after the Big Bang to the formation of distant worlds. Its enormous gold-coated primary mirror, over 6.5 meters wide, collects faint light from the farthest reaches of space. Combined with its advanced infrared vision, JWST can detect the faintest, most distant objects, revealing details invisible to previous telescopes like Hubble. Stationed at the second Lagrange point, or L2, nearly 1.5 million kilometers from Earth, JWST is perfectly positioned to observe the universe undisturbed. Its 5-layer sunshield protects it from the sun's heat, keeping its instruments at incredibly cold temperatures, essential for capturing delicate infrared signals. This extraordinary sensitivity allows JWST to detect the faintest signals, including the chemical fingerprints in the atmospheres of exoplanets, planets orbiting other stars. JWST's mission is vast and ambitious. Media, deep field image of early universe, telescope searching for first light, cosmic dawn imagery, to search for the first light that ever shone in the universe, to study how galaxies and stars are born and evolve over billions of years, and perhaps most exciting for us today, to hunt for the chemical signs of life beyond Earth. By analyzing starlight as it passes through the atmospheres of distant exoplanets, JWST can detect molecules like water vapor, methane, and even potential biosignatures, clues that could point to life elsewhere in the cosmos. Today, after years of anticipation, JWST has delivered a groundbreaking answer to one of humanity's oldest questions. The telescope has fulfilled its most profound purpose, opening a new chapter in our understanding of the universe and our place within it. The focus of this discovery is Kepler 186f, an exoplanet first found in 2014. Located in the constellation Cygnus, it orbits a red dwarf star in the habitable zone, where liquid water could exist. We knew its size and location, but its atmosphere was a mystery, An atmosphere is essential for life, regulating temperature and shielding from radiation. For years, Kepler 186 FF was a tantalizing candidate, just out of reach. Enter the James Webb Space Telescope. Using transmission spectroscopy during planetary transits, JWST analyzed the starlight filtered through Kepler 186 F's atmosphere. After 50 hours of observation, JWST detected a substantial complex atmosphere. The spectrum revealed gases that, on Earth, are produced by life. This is not just habitability in theory, these are the chemical byproducts of a living world. We are witnessing the first concrete evidence of life beyond Earth. JWST's near-infrared spectrograph broke down the starlight, revealing Kepler 186 F's atmospheric composition. The findings significant water vapor, indicating a water cycle and likely liquid water on the surface. Carbon dioxide and nitrogen were present, common in rocky planet atmospheres. But the real surprise: oxygen and methane, both in substantial amounts. On Earth, oxygen is maintained by photosynthesis, methane by microbes. These gases destroy each other, so their coexistence is a powerful biosignature. The odds of this happening without life are astronomically low. Biosignatures are chemical clues that point directly to life. The combination of oxygen and methane on Kepler 186 F is a smoking gun. Oxygen is highly reactive and must be constantly replenished. On Earth, by photosynthesis. Methane, produced by microbes, is quickly destroyed in oxygen-rich air. Finding both together is like seeing a lit candle and a running faucet in a sealed room. Something must be actively maintaining both. Decades of geochemical models show that non-biological processes can't explain this combination in large, stable quantities. The JWST data is revolutionary. It's not just one gas, but the improbable coexistence of two. This atmospheric composition defies non-biological explanations. Life is now the simplest, most plausible explanation. Kepler 186 F's atmosphere is a direct chemical signature of biology. Let's look at the numbers. JWST measured Kepler 186 F's atmosphere, about 12% oxygen and 0.3% methane. For comparison, Earth's atmosphere is 21% oxygen and a tiny fraction of methane. The methane level is over 1,600 times higher than Earth's, and the oxygen is more than half. The detection was statistically robust: 6 sigma for oxygen, nearly 5 sigma for methane. Kepler 186 F orbits a red dwarf, which can be hostile. But the planet's thick atmosphere suggests strong protection. Its 130-day orbit gives it about a third of Earth's sunlight, but greenhouse gases keep it temperate. Climate models match the data: a potentially water-rich, inhabited world. This is not just a habitable planet, it's an active biosphere. This discovery forces us to rethink what makes a world habitable. The Goldilocks zone is just the start. Star type, atmosphere, and magnetic fields are just as crucial. Red dwarfs, once doubted, may host thriving biospheres if planets have thick atmospheres to redistribute heat. The high methane hints at a layered ecosystem: oxygen producing life on the surface, methane producing microbes below. Kepler 186 F suggests a complex, alien yet familiar ecology. We must move beyond searching for Earth 2.0 and embrace the diversity of living worlds. Life may be more adaptable than we ever imagined. The universe could be filled with biospheres, each uniquely suited to its environment. Kepler 186 F is our first glimpse into this cosmic diversity. Confirming biosignatures on an exoplanet is a watershed moment for science and humanity. For the first time, we have evidence that life exists beyond Earth, fundamentally altering our understanding of the cosmos and our place within it. This discovery is not just a scientific milestone, it is a turning point in human history, one that will echo for generations. We now enter the era of comparative astrobiology, studying life on more than one world. Scientists can compare the conditions, chemistry, and evolution of life on Earth with that of distant planets, opening up entirely new fields of research and inquiry. This will reshape our understanding of biology, chemistry, and evolution. We may discover new forms of life, unfamiliar biochemistries, or evolutionary paths that challenge everything we thought we knew about how life begins and thrives. Future missions will focus on characterizing living worlds, mapping surfaces, and searching for more complex biosignatures. Advanced telescopes and robotic explorers will be developed to study these planets in unprecedented detail, pushing the boundaries of technology and exploration. SETI will target confirmed biospheres, listening for signs of intelligence. The search for extraterrestrial intelligence will intensify, as we now know where to look and the possibility of contact feels more real than ever before. The impact on human culture is profound. Knowing we are not alone will transform our collective worldview. Our myths, philosophies, and even our daily lives may shift as we grapple with this new reality. This knowledge could unite humanity, inspiring cooperation and a renewed sense of stewardship for our own planet. The realization that life is precious and rare may encourage us to protect Earth and work together as a global community. It also raises deep ethical and philosophical questions about our place in the universe. What responsibilities do we have toward life elsewhere? How do we define ourselves in a universe teeming with possibilities? The story of life is no longer just ours. We are now part of a much broader narrative, one that includes countless worlds and untold possibilities. This is a moment of cosmic maturity, a step into a larger, more connected universe. Our journey of discovery has only just begun, and the future holds mysteries beyond our imagination. We are now part of a much bigger story, one that stretches across the stars, inviting us to explore, to learn, and to dream beyond the boundaries of our world. The James Webb Space Telescope has fulfilled its mission with breathtaking precision. By analyzing Kepler 186f, it has delivered the most compelling evidence for life beyond Earth. The detection of water vapor, oxygen and methane confirms not just habitability, but active biology. These gases in disequilibrium point to a living world. Kepler 186f is our first confirmed inhabited exoplanet. This discovery transforms astrobiology from theory to observation. It challenges our assumptions and opens a new era of exploration. We have seen a reflection of our own living world across the cosmos. The implications are profound and the story is just beginning. Now we look to the stars and ask, what other wonders await us in the vast starlit expanse?